Welcome to my new video, folks. Another transmitter build. Look at this gem. You can build this yourself. Not a lot of soldering. Great sound quality. Go a few hundred feet. Put an amplifier on. Go miles. Right, it's got RDS. We've got a power meter for the RF. It's got sound input. RDS station name is a low, and like and subscribe. Is that focused? There we go. Great, isn't it? Build this yourself. Look, simple little transmitter, full RDS. Can you see it? There you go. Build this yourself. I'm going to show you in this video how to build this. Really simple transmitter to build. And look at it, see through it as well. With a microcontroller. All cheap. In all the parts for this are less than 20 UK pounds. So about $25. And the adjustments and modifications you can do to this are endless. I think it looks nice. Should power it up. Yeah, look. It's got a boot stream when you power it up. Bit of white noise. My design. Boot it up. And screen OK. Chip OK. Frequency set. There you go. How cool is that? And that flashing light just indicates that everything's working right. If that's solid, there's a problem. I'm going to show you how to build this yourself and have your own one. Yeah, like I said, very easy to build. A few components. You've got the Arduino Uno copy. I don't even know if this is real. I got it from AliExpress, but really good board anyway. You've got a transmitter board here, an Si4713. These are really cheap. And the screen, it's about the OLED screen, 0.96 inch. Very good screens as well, less than £2, and a button. And all you need then is a little bit of code that I'll supply. Send me a message, I'll send you the code. And you can upload the code then with Arduino IDE. And get it all working, just like this one. Because I know a lot of my subscribers do actually build the transmitters I show. But don't be afraid, a bit of soldering, upload a bit of code, and you've got a fully functional, very versatile transmitter. Click on it. It's straight through inside. Wires at the back of it. Build it yourself. Dead easy to do. I'll supply all the code and everything else, and you can have great fun. Okay folks, here's the parts. All this for less than 20 quid, less than 20 UK pounds, so about 25 US dollars. There's this switch. The switch is a bit bigger than I thought. That was a pack of 5 for £3.99. That's the Arduino Uno copy, fake, whatever you want to call them. Well, it's open source in it, so it's not a fake. There's a screen. £1.64 from AliExpress. That was also AliExpress. That would be plus their shipping fees, which ain't a lot. There's a screen, Amazing. £1.64. Very cheap. That's the actual transmitter IC. £3.39. Very good value. That's the case. Don't get these cases from AliExpress. They're a bit thinner, so they haven't got the room on top. This one from eBay. They're much taller. They're much higher. So you can fit a screen in, no problem. What was that? £3.99. They're good value actually, good quality. And that's the cables. I'm only going to use a fraction of them. So that's the cables, case, the transmitter itself, the screen, the microcontroller, the switch. There. Should we put it together, folks? As you would know, well, you might know, I'm not sure if you know about microcontrollers or how long these Arduinos have been around. Oh, it's quite a good copy of this actually. Works just like the original. Bit naughty though, saying Arduino Uno on it. But never mind. Anyway, the reason I'm using one of these, they are quite chunky compared to microcontrollers of today, like the CSP. The CSP is much more powerful, and it's a fraction of the size. But the reason I'm going to use this chunky thing, obviously it goes in a nice big case and I can fit everything inside it. So basically it becomes the chassis, or the case for the transmitter. So it makes total sense to use this big thing than one of these, because if I use one of these I'd need to make a case, wouldn't I? So ideal to use one of these that have been around, I think since 2008, is it, or 2009? 16 megahertz versus 240, I think, with this ESP. And another thing with this ESP it's got Wi-Fi and Bluetooth. These are great. But these have still got their uses. They're very reliable as well and durable. This transmitter, obviously, has been around a while as well. This is an Si4713. It's a feature-rich FM transmitter IC from Silicon Labs. These are great. They won't work on their own. I need that. I need that to be programmed with some software, which is basically firmware. So we'll get to the code a bit later. There is some code you can download online, but obviously it won't support that screen. I've modified the code. I've heavily modified the code so it uses that screen and also the button there to change the frequency. But the code is free. Just contact me and I'll send you the code. Getting back to this transmitter IC, obviously needs a controller to use it. Frequency support is from 76 to 108 megahertz. Great thing about this little transmitter IC, it's got RDS for sending station name, song information, a summary of any key features, anything really. It's also stereo, supports stereo and mono. Pre-emphasis is 50 or 75. I think us in Europe are 50, America and Canada and a couple of other countries are 75, so you can adjust that. Like I say, it's got an integrated RDS. It's got digital audio support. Well, the way this is going to communicate with these is with the I2C protocol. So you can see on top of there, I think you got the clock and the data. So basically you've just got the power and clock and data. So just 4 wires for the screen. Same with the transmitter as well. So basically the microcontroller is the master and these are slaves. So it's a very easy way of rigging them all up. Well, the way I'm going to put this together, I think I'm going to put the power pins of the screen in. I can slot that straight in, so it's just going to sit there nicely. And the transmitter, hopefully, get it about here. Something like that, folks. I'll show you sort of what we want to do. That's the bottom of the case. Lovely cases these are. Superb quality. Highly recommended. So that'll go in there actually. That's just clicked in lovely. So you can see. They look nice. Right, so hopefully the screen's going to go about here. Transmitter roughly like that, but it'll be lifted up a bit. We'll see. And hopefully the cover just goes on top. So it's going to look something like that. Cool. Now I just thought about the wiring on this. I ain't going to use these headers. I ain't going to use the pins going into the top of the headers here. I'm going to do a more permanent solution. Because I don't think that looks very nice, because this is obviously, this controller is only going to be used once for this transmitter, so what I might do is just wire it up underneath permanently. It'll look a lot neater, won't it? So I'll just go underneath and wire direct under the pins. I think we'll do that. This is the screen, so I'll only need half of it. A little bit flew across the room. This will be for the power only. Always use flux when soldering. Makes soldering a lot easier, gives better results. Okay, let's get the power soldered in for the screen. Lovely. As easy as that. I'm not sure how we're going to do the wiring yet, but I'll just do it as we go along. So I'll just take a couple of these off. It's going to feed in through the back, the clock and the data. I'll just feed them through the back like that, and we'll solder them in. Okay, let's get the data and the clock soldered in. Lovely. As you can see, that's all the screen wired in. Simple, isn't it, really? 2 power pins, clock and data, all done. Just push these to the side there, so it's no higher than the actual plastic here on the header pin. So that's it, that screen's all done now, that's ready to fit. Okay, next we're going to put in the data and clock wires on the transmitter. Okay, first wire to wire in on the transmitter will be the blue. I'll try and keep them all the same colour, so it'll be the SDA, the data. Okay, first one to be soldered in is SDA, the blue lead, blue cable, data. Next one is the SCL clock. That's the data and clock. Next one is the reset which goes from reset on here to pin 12 on the controller. Oh, reset pin next. Okay, so we've got our reset, clock and data. Next, power. Get the ground in. Get the power in now, 5 volts. Let's just clean off some of this flux. Just look at mess. Okay, that's the screen wired in, and also all the wires in the transmitter. That looks a bit cleaner now, doesn't it? Not too bad. That'll do. Just got to fit it all in now. Okay. I know a lot of my subscribers do build what I show in my videos, so I'm going to position this transmitter about here. I hope you can see that. Right, so obviously the data and the clock pins with wires are going to be going to the back of the OLED screen. So just cut them to length. So make sure you don't cut them too short, because you'll be doing all the wiring again. Yeah, so it'll be about here, I think. Tin them up. Okay, that's the data on the clock, cut to length so that can be soldered to the back of the screen. And from the back of the screen, the two data and clock will begin to the controller board. So very simple. I'll show you in the diagram. Okay, I've just turned them upside down now, so get ready to wire these into the back. Okay, I'm just going to solder the clock together at the back of the OLED screen. Lovely job, like. Now we're just going to solder in the two data at the back of the OLED. Okay, as you can see now, the I2C now are both connected up from the transmitter to the OLED screen. And what we'll do then, we'll have the two wires from the I2C bus go to the controller next, which is these here. I want to try and hide these wires as best I can. Like I say, I'm not going for the top of the headers, I'm going to go probably around the side of the circuit board and underneath. I should just have enough room. What we'll do now is plug the screen in. That goes into the 5 volts on the ground. Should be about there. I see it holds in place now, doesn't it? That's a bit fiddly bit now. Just got to sort of move the wires around where we think they're going to, well, where they are going. But so obviously the power leads are going to have to go across the main IC of the controller and around the back here, just underneath the board there. This is our reset. This purple lead, so that can go under here. It might be a bit hard to show on screen, but the power leads I'm just going to feed through. Like the headers have got a little gap in them at the back here, so I'm just going to feed the wires through there, bend them round and solder them in the back here. Can you see that? So I'm just going to turn the board round now. Sort of cut the wires to length for the 5 volt and ground. Board's cut slightly longer, better slightly longer than shorter. Now when soldering underneath, it's going to be awkward for me because I'm holding this and I've got to hold the soldering iron and everything else, so the soldering probably might look too brilliant at the start, but I'll finish it on after. Just make sure you count the pins along. That's it. Okay, I've done the ground. Next one will be the 5-volt supply. Obviously this is going to the transmitter, isn't it? Oh, I've got to tidy that up a bit. Okay, that's the power in. They ain't touching, I've just checked with my multimeter. While I'm under here, I might as well put the wires in for the frequency adjustment. So that goes from pin 8 to ground. I have to pull down to change the frequency. Like I said, it's a bit awkward for me, this is. I'm leaning over the lights, the camcorder and everything. So there's two grounds right next to each other on this Arduino board. So, like I say, the next ground there now is for the frequency. That's them three in. Okay, next one is pin 8 for the frequency change. Lovely. Before we put this into the case, we'll definitely be cleaning it up. Just give it a little spray and looks the best on it, the flux. Well, we haven't got too much wiring left now. Alright, we just move the transmitter into place. We've got the reset which goes to pin 12, so we'll feed that underneath, do that, and we'll do the data and clock from the OLED to the controller. Obviously that's connected to the transmitter too, and so it wires the whole lot in. Should we get that done? Okay, I'm just going to feed this purple wire around. I think it's just going to reach, you know, it should have had it a bit longer really. That's going to go to pin 12 underneath. Okay, counted them along, it's a fifth along, so it's pin 12. So make sure when you do this you get the right pin, because it wouldn't work if you don't. That's it. No, that's pin 12 in, the reset. Great. Not a lot left now, is there? Okay, next one is the SCL line from the OLED to the controller board. That goes on A5 on the controller, right on the end. Right, next one is, it goes to A4 on the controller board. This is the data. Lovely. That's underneath done. Almost there. Before I put this controller into the case, I'm going to have to just slightly cut around the case there, just so I can get the audio socket in. I'm going to have to do both sides of the case, the top and bottom. So just be very careful doing this bit. Just use a marker pen or something, so you can roughly mark out where you need to cut. Hopefully you can see that. Now be very careful here, folks. You don't want to destroy your case. That's it. I've just done left and right. That mark. Now just use a pair of long nose pliers or whatever. Break that about. Lovely. Just use a little file. Just file it nice and smooth. Try and get it round as well. I've got an Arduino file for this. It's half round. I think it's a jewellery file. Both sides up and just go round. Lovely. Just take your time with this bit. Well folks, I think we are ready to put it into the case now. I've cut that out nicely. So it looks alright, doesn't it? Right, your 2 wires for your switch, make sure they're at the front, because I think the switches go to the right side. That's what we're thinking anyway, so just slot it in. Hopefully the wires, there's a gap there, so they should fit in there nicely, yeah. Alright, that's the one side. Oh yes, that just clipped in. Lovely. You see what I cut it out there, can't you? Oh, that's a decent fit, isn't it, eh? It's getting there now, not a lot left now. That does fit in. Lovely. Be about here, shouldn't it? Now, as you can see now, fold that nicely. That's good. So they should go together now. A bit of luck. Oh, lovely. Nice satisfying click. Yeah, so that fits perfect. Let's try to open it. Yeah. What we'll do, we'll hot glue the transmitter in place, because obviously if you push the lead in, it's just going to push it forward. So we will hot glue that in, but we won't do that until it's all been tested. We don't want a problem, do we, if we hot glue it all in and got to remove that stuff. It ain't easy to remove. Next is the switch. We're going to put it at the front, because I don't think there's any room on the side, so we'll just have to bend the leads, bend these leads flatways, because I can just about get it in the case, I think. A bit like that. Just mark out where to drill. Now be very careful drilling, don't slip. Don't want to wreck the case. Lovely art. Oh, that's it. Oh, that's it. That does. Lovely. So, tighten that up. All 2 wires you can see sticking out here, obviously for the frequency change. So I've just got these to length. That's it, they're cut to length. I won't solder them on yet. I'll get the antenna in first. Oh, we'll do the antenna next. In this case, there's a little hole here. That's for the reset switch on the Arduino board. We'll just call it an Arduino. It's a copy. But what we'll do, we'll feed it through there. Once it's all been fully tested, I'll actually just hot glue it on the inside slightly, so then it doesn't obviously get fatigued. Otherwise, if you don't do that, it's just going to work itself loose and drop out. So we'll solder the one end in. Okay, let's get the antenna soldered in. Alright, let's just get the switch wired in now. I think that's all the soldering done, folks. Should shut the lid down. Hopefully everything is good. Bang on. Looks good, doesn't it? Transparent transmitter. What we'll do now, we'll pop this over to the computer and using Arduino IDE we'll install the code. Now this code is available if you want it. If you want to build this, like a lot of my subscribers do actually build what I show, right, contact me through YouTube and I'll send you the code. not a problem. It looks nice, doesn't it? And installing the code is very easy. Very easy. I think before we do that, I do actually want to just pop the cover off. I want to pop, see the screen protector, I've got to get that off. Lovely. Before I actually plug it in, I've just lifted that circuit board, the transmitter board, off the main board. I don't want you shorting on anything. Just go and plug it in. I haven't even tried this. I took it out of the pack and done the done the video. So just plug it into the computer. You should have a sketch running. That just blinks the LED. So here we go. Yeah. Is it flashing? Yeah. Bang on. So now the controller's good. Good stuff. We're just going to double click Arduino IDE, because that's the software we're going to install the code with. Now if you're going to build this, folks, like a lot of my subscribers do, so it's a very easy transmitter to set up, you know, not a lot of soldering. Anyway, you're going to need a file. So that file there that's highlighted, Adafruit, Si4713, library, master, that's the file you'll need. It's only 342 kilobytes, so it's not even half a megabyte. Right, you contact me on YouTube and I'll send you that file. Right, or you could just download it from, I think, GitHub, and you'd need to install all the screen support and everything then as well, and the files for the code for the frequency change. Anyway, I'll have this running, won't I? Arduino IDE. Right. Now once you've installed them files, it's very easy to do. Well, they'll show under examples. You come down, 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 down. Adafruit. There we go. Si4713. So once you've installed them all, you'll see them here. All the examples. Just click them. Just wait for that to load. That'll be the code. Right, as you can see, that's still running. The sketch that come with it. So basically that's just the blink sketch. Wow. Right. So what we need to do is install the files. You just see them show up on screen out. Right, it's quite a long file. Right, so to get this going, we just need to upload that code to that. Yeah, you see where my mouse is there. Upload. Click upload, and now it's going to upload the files to the transmitter. Oh, you can see it's receiving summit. Oh yes, booting up. I like it. Wow, there you go, folks. It's working. Frequency 103.4. RF power is set to 115, which is max. Sound input is -56, there's no input at the moment. Station, that's the RDS, is a low. And RDS scrolling, it would scroll on a FM radio, but I haven't got it scrolling on there because I know from experience in the past that'll cause slight noise interference, so we'll just keep it static. RDS, like and subscribe, if you could please. Oh, that was great. Worked first time, didn't it? No problem. Oh, actually, should we try the frequency change? Yeah. So each click of this, as you can see, the frequency going up. Now if you want to come down the frequency, you just hold it down for more than 3 seconds. And it'll start going down the frequency. There you go. See? So you just need one button to control the frequency. Easy enough, innit? Right, should try the sound now. Just a quick note, if you've never used anything like this, like Arduino, IDE, it's simple to use. When you do load the sketch, most problems people have is it's not detecting your USB that's plugged in. So click Tools, click Port, and just make sure your port's ticked. As you can see here, COM9, Arduino, and make sure your board is set up as well. Arduino Uno board. So just make sure that's highlighted, your right board. There's hundreds of boards there, so just make sure you've got the right one selected. And when your main code's loaded as well, you can change your frequency here. I think frequency's at 14, just here. I've got it set at 103.4. So just there, where I'm moving the mouse, you'll adjust that bit there. And if I come further down to line 25, that's where you'll change your RDS information. That's scrolling RDS on the radio. So you can put a few more letters in there. I've just put like and subscribe. So you'll change that, then you'll upload here, and obviously upload to your controller board. So come down to line 84. That's your RF settings. Set to maximum RF. I think the values are 88 to 115, so set in maximum. Good enough for your garden, a couple of doors down the road, end of your road, end of the street. If you want more power, put an amplifier on it. I will do a video putting an amp on. Where we are going now, line 188. Line 188, display print hello, station name. So that's RDS again, that's your station name. So fill all these out before you upload. That's how you update all the RDS information and RF transmit power plus frequency. So it's quite easy to use. Just a note, as well as the library I'm going to supply, which will be the Si4713, you'll also need one or two other libraries for the screen. As you can see here, you'll also need Adafruit, GFX, and the one underneath as well, Si471306, you'll need that as well. Very easy to download. Click Tools, where are we? Manage Libraries, and just type them in now. Type them in out, and they'll come up here and you should just install them in. Like if I did SI, it comes up there, doesn't it? 4, 7, there we go. We've already got that one, so it says installed, so just use the search bar up there and then install the libraries you need. That's before you click upload. So just make sure you got all the libraries installed. And next we're just going to test the sound. So just going to plug this lead in. I'm going to have to be very careful because I have not glued it in yet. I'm going to plug it into my phone and we'll try that. There we are, plugged in into the phone. Here's our radio. Does the audio work? I'm going to plug it into. Let's just plug that in. I know you can't see anything. There we go. No, it's booting up. Boots up. Screen OK, I see OK. Set the frequency, hold on. Perfect. I'll just click play on that. Play on that. And you see the sound level now. See the sound level moving now, like -3. Oh, it's quite loud. I think it's a -0. It's too loud. So we know it's got sound input and that's working. Lovely, full signal. Working bang on, man. Lovely. Good on it. See the flashing light as well, I forgot to tell you that. If that don't flash is the problem. It ain't got a power LED, it's beyond the transmitter, so you can't see it, but I'm too bothered about that. Good on it. She's not gluing in now, the board and the antenna. Okay, here's the messy bit. I don't like using the hot glue. Well, we do need a good bit on here though, because we don't want it moving, do we? Once you put the audio plug in. So there's plenty there. You're going to see it anyway. Just make sure you get it in place there. Oh, brilliant. That's it. Just let that dry for a second. I'm just going to drop a bit around where the antenna goes through the case. Stop any fatigue really. Might look a bit of a mess, but don't want loads. That'll do. Okay, we're almost complete. Good on it. So just clip it in now. Yes. She's all done. Isn't that nice? Quite happy with that actually. Should give it a little test, a little range test. Why not? Okay, I'm in the spare room. Just going to plug that in. 1 minute, just put the camcorder down. There we go. That's booting up. LED, blah blah blah. Great. Let's boot it up. Just play this song. There we go. That's coming direct from the transmitter now. There we go. And so the prototype. That was the old prototype. Just to make sure it worked. Which it did. Build it yourself, folks. Very easy to build. Not a lot of soldering. And the code's simple. Easy. Got solid walls in this house. At the back of the house. Still full signal on that. It'll go hundreds of feet. Then to your garden, then to your road. Not a problem. That won't too upper. In the back garden now. Build it yourself, folks.